this is an Algebra 1 video. We are combining two sections today, Chapter 6, Sections 3 and 4, because both sections are dealing with elimination, and I don't think it's necessary to break them up into two different sections. So we're going to combine them together. And elimination, we already saw how to solve systems by graphing, and we saw how to solve system of equations by substitution. And so now we're going to try our third and final method for solving a system of equations, which is elimination. Now with elimination, the bare bones gist of what we're doing is we are basically going to add the two equations together in the hope that one of the variables will cancel, aka eliminate itself. So the first examples that we're going to be doing are going to be the easiest ones, where you don't have to do anything in preparation to add the two equations together. So in other words, the goal is for them to eliminate. The only way that the variable will cancel when you add the two equations together is for one of the variables, whether it be the x or the y, to have opposite signs, positive and negative, and the same coefficient. So a positive 6 will cancel with the negative 6, because when you add a positive and a negative, you'll get 0. So that's the goal. So we can see here, when I add these two equations together, 4 and 3 is going to give us a 7x, but a positive 6y and a negative 6y is going to give us 0y, or hence it cancels. And then 32 plus 3 is going to be 35. We then solve for the remaining variable, which in this case is x, and we know that 35 divided by 7 is 5. So the x coordinate of my solution is 5. At this point, we can actually resort back to substitution, and we use either one of the original equations, and we replace the x variable with what we just found in the x for our answer. So here we have 4x plus 6y equals 32, which is the original first equation, and we put a 5 in the place of x, so we get 20 plus 6y equals 32. Subtract 20 from both sides, and 32 minus 20 is going to be 12. Divide both sides by 6, so y equals 2. We write our solution always as an ordered pair. X coordinate goes first, y coordinate goes second. So our solution for this system is the point, or the ordered pair 5, 2. So again, these are two. This is an example where we don't have to do anything to the equations beforehand. We can just go ahead and add them together because they're already opposite coefficients. So now I want you to try these. I will give you a little hint for part B. You have to put this in the right order first before you get started. It says 4y plus 3x. Those should be written in the opposite order. So you might want to fix that before you continue. So now we have example 2 is a little bit of a word problem. So in this case, we have to start by setting up our system first. So we have negative 3 times one number. So I'm going to go ahead and call that number x. So negative 3 times the number plus 5 times another number, and we'll call the other number y. So plus 5 times y is equal to negative 11. Then it says 3 times the first number, which was x, plus 7 times the other number, which was y, is negative 1, and they want us to find the number. So aside from actually setting up the equations, everything else in this example is going to be the same. We can tell this time that in the previous example, we had the variable over here that was, where's the other guy? We had the y's that canceled, right? But this time our x's are going to cancel. And that's okay. It doesn't matter which one you're going to cancel. So when I add the two equations together, negative 3x and positive 3x is 0x, so they cancel. 5 plus 7 is 12y. And negative 11 minus 1 is negative 12. We divide by 12, and y equals negative 1. Then we go back to either one of the original equations. Negative 3x plus 5 times y equals negative 11. And we're going to replace the y with negative 1 because that's what we got in the first part. And then we solve for x. So negative 3x minus 5 equals negative 11. We add 5 to both sides. And negative 3x equals negative 6. Divide by negative 3, and x equals positive 2. When we write our solution, we always want to write it in alphabetical order. So the x coordinate will go first, and the y coordinate negative 1. And so the two numbers that they're talking about here are 2 and negative 1 for this example. So now we'll have you try this little guy, and then we're going to move on to our word problem over here. And I did skip some of the examples in the textbook because we're doing two sections together, so I didn't want to do like 10 examples, so I picked some from each section. But here we go. Again, we need to write out our word problem before we can get started. It says Cheryl and Jackie work at an ice cream shop. Cheryl earns $8.50 per hour. So what we're going to do is we're going to get some variables up here, and we're going to call X the hours for Cheryl, and we're going to call Y the hours for Jackie. All right, so now it says Cheryl earns $8.50 per hour, so $8.50 per the hour, and Jackie earns $7.50 per hour, and Jackie's hours are Y. And it says here during a typical week, Cheryl and Jackie earn $299.50. So their combined salaries are going to be $299.50. So there's one equation. And then we have, then it says the next thing, 1 week, Jackie, which is Y, doubles her work hours. So Cheryl has the same hours, so she's still going to be $8.50x. But Jackie is going to be $7.50. And instead of putting a Y, we're going to put 2Y because she's doubling her hours. And in that case, when she doubles her hours, the girls earn $412. How many hours does each girl work during a typical week? So we need to solve for X and Y. Okay, so what's going to happen here is we're going to have 850x, and we want to kind of solve this right here. 750 times 2 is what, 15? So now instead of using this equation, we can use this equation and that equation. So what we're seeing now is that when we add these two equations together, we're not going to get anything to cancel because 850 plus 850 is going to be 17, not 0. So this is where we start getting into the next stage of problems where you have to start doing something to the equations before you can get them to cancel. So what you want to do is you want to multiply one of the equations by something in order for them to cancel, because you want one to be positive and one to be negative. So since these both have the same 850, all we need to do is multiply by -1, and then that will change the second equation to negative 850x, and then -1 times 15 will be negative 15y, and negative 412. So now this equation is gone. And the two equations that I'm going to be adding together are the very top one here and the orange one down here. So 850 minus 850 will cancel. And then you have 750 minus 15y is negative 750y. And then we have 299.50. So $299.50 minus 412, and you get negative 112.50. Then we divide by negative 750 on both sides. And then y is 15. Okay? So y equals positive 15. So now what we need to do is plug that into one of our equations. So I'm going to go 8.50x plus 7.5 times y, which we know is 15. And that's supposed to equal 29950. Sorry for running out of space there. Okay, so we got 7.5 times 15, so we get 850x plus 11250 equals 29950, and then we want to subtract the 1250 from both sides, so 29950 minus 11250 leaves with 187. Divide that by 850 and you get 22, which means that Cheryl worked 22 hours and Jackie worked 15 hours that week. And that is how you do that little guy. And at this point, we're now moving into, this is your do-it-yourself number 3, but we're now going to be moving into our last 2 examples, and they're actually going to be coming to us from 6.4. And now you will see, again, a similar scenario to what we saw in the previous example, which is the fact that neither of these have opposite sign. There's no positive, negative going on. And neither of them have the same coefficient. So this is a 5 and a 2 and a 6 and a 3. So we're going to have to multiply the equations by a scalar, by a number, in order to get that to change. So it doesn't really matter which variable you choose. So I'm just going to go ahead and tell you why I'm going to pick the y. You have a couple of options. The least common multiple between 5 and 2 is 10. So that would mean that I would have to multiply the first equation by a 2 to get 10 from this 5. And I would have to multiply the second equation by a negative 5 to get negative 10. If I were to do that, then I'd get positive 10, negative 10. They would cancel. But that would require 2 steps. If I choose to go with the option of the y's, the least common multiple between 6 and 3 is actually 6. And since one of those numbers is already 6, I only have to multiply one of the equations instead of multiplying both of the equations by a negative 2. If I multiply this by negative 2, I'll get negative 6y with a positive 6y, and it'll cancel. It'll be less work for me. So I want to be very clear that you can do it the other way, and you'll still get the same answer, but you want to try to find the variable that will give you the least amount of work. So in this case, I'm going to choose to multiply by negative 2 on the second equation, so that I can eliminate the y variable. So that means that you have to multiply everything by negative 2, not just the y. So 2 times negative 2 will give me negative 4x. 3 times negative 2 will give me negative 6y. And negative 5 times negative 2 will give me a positive 10. Then I'm going to go ahead and bring down the original equation, which was 5x plus 6y equals negative 8. So this is now my system. And when I add those two together, 5x minus 4x is 1x. These y's are going to cancel. And 10 minus 8 is 2. And just like that, x equals 2. Then I'm going to go to my original equation, 5 times x plus 6y equals negative 8. And since I discovered over here that x equals 2, we replace the x with a 2. And then you get 10 plus 6y equals negative 8. Subtract 10 on both sides. 6y equals negative 8 minus 10, which is negative 18. Divide both sides by 6, and y equals negative 3. So our solution today will be x is 2, y is negative 3. And that's how you do elimination involving multiplication. So now we're going to have you try these little guys. And then we'll go on to our last example, just to give you one more shot at how this works. And again, I need to decide whether or not I can avoid multiplying both equations. And so it looks like in this case I don't have that option. If I try to eliminate the x, the least common multiple between 4 and 3 is 12. So I would have to multiply both equations by something. And the least common multiple between 2 and 3 is 6. And neither of these is 6. So again, I would have to multiply both equations by something. So in this case, there's no shortcut. I will have to multiply two equations by two different numbers. So at this point, it doesn't really matter which variable you want to go with. But I'm going to go ahead and multiply the top by a -3. And that will give me -12. So I'm going to come over here and rewrite the system. I'm going to get 4 times -3 is -12x. And then 2 times -3 is -6y. And then 8 times -3 is -24. Please don't forget to multiply the constant as well, not just the variables. On the bottom equation, the second equation, I'm going to multiply that by a +4. I'm not multiplying them both by negative because I want one to be negative, one to be positive. So 3x times 4 is 12x. 3 times 4 again is 12y. And 9 times 4 is 36. Now I can go ahead and add my equations together. The 12x minus 12x will cancel. 12y minus 6y is just 6y. And 36 minus 24 is going to be 12. Divide both sides by 6. Y equals 2. My original equation over there said 4x plus 2y equals 8. And in this example, or this process here, we found that y equals 2. So replace that. And then you get 4x plus 4 equals 8. Subtract 4 from both sides. 4x equals 4. Divide by 4 on both sides. And lo and behold, x equals 1. So my solution is 1, 2. And that is how the cookie crumbles. So now you can try this little guy. And once you have completed this example, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.